welcome to another Unity 5 tutorial. Today's tutorial is going to be on creating a NPC or a non-player character with some simple artificial intelligence. So to begin with, I've got this skeleton guy that I've downloaded from the asset store. He's free, so if we just look at the asset store, you can see if you type in fantasy monster, you'll get this skeleton, and he's got all the animations that we want. So we want an idle, we want a walk, and we want an attack animation. So he's perfect for this example. Of course, you can use your own. So in the scene, what I've done is I've added him into the scene as well as an FPS controller. Now the FPS controller you can grab from assets, import package, and characters. Then when that imports, you'll find your first person controller in standard assets, characters, first person character, prefabs, and I've just grabbed this first one here and brought it in. So you just need something that you can walk around the scene with. Also, you need to have your own player object so that we can test the distance between you and the skeleton and determine whether he's going to attack you or not. So we're going to program this skeleton to only attack us when we come within a certain distance of him. Other than that, he's going to be quite disinterested in us. So to begin with, we're going to create some code, which I've already got here. Now, if you're following along, create a C# file and call it chase. And then in that C# file, if we open it up, you'll see that I've got this. First of all, we've got a public transform for the player, which will be an exposed variable in the inspector, and we can pass through our FPS controller to there so that the skeleton knows the distance between you and him and where you are. So this code actually goes on the skeleton itself. Now in the update loop, we're going to test for the distance with vector3.distance between the player's position and the skeleton's position. And if it's less than 10, then we're going to work out the direction from the player to the skeleton, and then use that direction vector. Okay, so it's going to be a line between the player and the skeleton, or as far as the skeleton's concerned, from his point of view, it'll be the direct line between him and where you're standing. And then you're going to make him rotate towards that direction. Not snap all in one go, but rotate with a slurp function, which will take us very slowly around, which looks a bit more natural than if he just snaps and looks at us. Okay, so if we save that and then switch back to Unity, what I've done with that code is attach it to the skeleton. So if we click the skeleton here, you can see that that code is added down in the inspector. Then you want to grab your FPS controller and just drag it and drop it on the player. So it's going to pick up your transform. Now if we run it and just wander around, notice that the skeleton's now following us, and he's not snapping either. It's more of a fluid flow. If I get closer, can you see what happens? He actually bends back. Now why is he doing that? It's because we're calculating the direction vector between him and our player. Now, if you're standing above him, then that angle is going to be much sharper. So he's just going to constantly keep moving for us in that way. Now, you probably don't want him to tip over backwards like that. You probably just want him to rotate around his y-axis, which is the up axis. So that can be easily fixed in the code. Let's just go back to the code. So here we're calculating the direction between the player and the skeleton. What we want to do is take the y-axis, or the height difference between us and the skeleton, out of the equation so that we're not rotating upwards. And you can easily do that by just setting the direction.y value to 0. And that will get rid of it completely. Now if we save that and go back and run, And we just wander up to him and then move around. You can see that he's not tipping over anymore. Great. So now he's aware of us. When we get within 10 of him, he'll start to follow us around. What we want him to do now is to actually come towards us if he's become aware of us. And then at some point, we want him to lose interest if we get far enough away. So to do that, we'll just add a few extra lines of code. Right, to make him move forward when we've alerted to our presence, I guess. So if it's less than 10 distance between him, we've worked out the rotation angle so that he looks at us. And now down in here, we can actually add some code that says if that direction vector that we've calculated, which is the line between the skeleton and the player, if the magnitude of that, magnitude is just another word for length of a vector. So the magnitude, if that's greater than 5, then we're going to translate the skeleton in 0.05 in the Z direction. Now the Z direction for our skeleton is its forward axis. Let me just save this and I'll show you. So save it, go back. Now the skeleton, if you select it and you have a look over in the scene, is you get this little axis system. The blue is your Z axis, which is also called the forward axis. Sometimes, depending on where you get your model from, its direction that it's facing might not be along this blue axis. It might be turned and facing along the red axis, in which case you would have to use a translate that pushes it along the X axis. Most models nowadays, the new ones, do use Z as the forward. In the old days, things used to be flipped around. But anyway, this guy's from the Unity store, so we can assume, and quite rightly, that he is facing along the Z axis. Right, so we've saved that. Let's just run and see what happens when we move up to him. As we get within that 10, he starts to follow us. And then when we move outside of that particular range, he stops following us. So he's only going to follow us for a little while, as long as we stay close enough to him, which is what we want. We want to be able to outrun him, and then he gets bored with us and leaves us alone. Okay, now because he's actually left us alone, he's also not even turning around because he doesn't really care. He's only going to turn and face us if we are within that 10. Okay, great. So that works really well. Okay, so he's moving, but he's not animated to move. So to make him seem a little bit more realistic and threatening, you will want to add his animations on. Now, I've already created this animator controller here, which you can do under Create and then Animator Controller. And once you've created it, what you want to do is select the skeleton. You'll notice he's already got an animator on him, and you want to drag and drop this over here onto his controller. And this will be our little state machine that shows us how the animations work. Now, I've got a number of other animation tutorials that you might want to look at to get like a basic view of how this works. Though he's not going to have a lot of animations on him, so there's not a lot of work to do. So this is our animation controller. Now we need to find his animations, which are in Skeleton, Annie, and you'll find them all here. If their names are too long to fit here in the project, you can actually just select it and you'll see the entire thing. So this is his attack, which we want. So we just drag that into here, his attack. And we also want an idle. There's an idle animation, and we want a walking animation, which is this one here. All right, so the orange means that it's the default. If we now run this, he will immediately start attacking because it'll just play that animation. Okay, right, that's not what we want. We want him to be idle. So select the idle state, right click and go set to default. It will now go orange, and when we run it, he will be idle. If we just watch his idle animation, it's quite a long idle animation, this one. Now, one issue that we immediately notice is that our mechanics, as far as him following us, are still working, but he's stuck at the end of his idle animation. So let's just stop that. And the reason is that this is not set to loop. The same thing if he's walking. If I set this to default and then we play, watch what happens is he will walk and then he stops. Okay, so the walk cycle isn't set to loop, but we want all of these things to loop so that it doesn't sort of stop and become static. Okay, so to do that, you need to find, again, these animations that are in the Annie folder. Select them. Okay, so this is the attack. Then over in the inspector, go to the animations tab, and just underneath this timeline thing, click on loop time and then loop pose and click apply. And you want to do that for the 3 animations that we're using. So that's the idle and also the walking. Great. Now we're going to set this back to the default state, idle. So let's just run that, and you'll see that in the animator window, you can see a blue bar on the idle animation. That's showing how far through it is running, and you can see that it's just looping over and over again. Right. Now the next step is to connect all of these animations with transitions so that you can play from one animation to the other, and then we can set those transitions up to be controllable by code. Okay, so I'm just going to move these over so that you can see them a bit clearer. To create a transition between one state and the other, it's just right click, make transition, and then click on the one you're going to. And we want to come back this way as well. We also want to be able to go from walk to attack and back the other way. And then we also want to go straight from idle to attack and then also back the other way. Now, at this point, when you have a straight transition and no conditions on these transitions, then these animations will just run. Now, because this has 2 transitions coming out of it, I actually don't know which one it will choose, but if we press play, we can see what happens. It's going to run the idle, and when it's finished with the blue bar, it's gone to walk. Okay, and back to idle. So it's doing that sort of a loop, but we want to be able to control that. So we need to create some parameters. Up in this top corner, you've got a parameters list. We're going to click add, and we're going to create booleans. So click on bool, and then in here, we're going to create one called is walking. I've used a capital W and smaller for the rest. That's just the format that I use. And I'll create another bool and call that is attacking. And one more, bool is idle. Now, we're starting in an idle position, so I'm just going to click that on. Okay, now we need to control these things with the code so that when we get into a particular distance of the idle, it will then start walking towards us, or if we're really close, we're going to attack. But before you can control them with the code, you need to link them up with these transitions. Otherwise, you'll just be changing these values and it won't be affecting what's going on in here. So going from idle to walk, if you click on the transition, we want this to occur when is walking becomes true. So we select the transition and then go over to the inspector. And in the conditions list, we're going to add a condition. for is walking true. Now this comes up first because it was the first one in the list. Right, then we go through each of the other transitions. So this one will be when is idle becomes true. Then we've got is attack becomes true. This one will be is walking becomes true. And then we're going from idle to attack, which will be when idle becomes true. And then we're going back when idle becomes true. Did I just say idle for that one? That one should be attacking. Okay, great. Now let's just have a look what we've got in our code. Right, so in the code, we've got our animator object here at the top. So we create a static animator, anim. Then in the start function, it's going to be set to the animator component that's attached to the skeleton with a get component statement. So we always need that, otherwise the anim's going to be empty. Now, down in our code here is after the rotation has happened, which means we're close to the skeleton, then we want to set the is idle to false because we're not going to be idle anymore. We're going to start walking. And then if we're within 5 distance of the skeleton, we're going to set is walking to true. All right, so let's just save that and run it. And if I walk up to him, okay, he's now going to continue walking. Notice we're out of the distance where he will keep following us because we need to turn off the walking animation and set him back to idle when we have walked too far. So we need to add a few more other conditions to turn on and off all of these triggers that we've created, or Boolean values, I should call them. All right, so if we have a look at the code now, what I've done is just put in all of the other states for you to see how it's going to all come together. So we set idle to false if we're within a certain range. Okay, then if we're even closer, if we're still 5 away, then we're going to keep walking towards the player, which means we're going to set is walking to true and is attacking to false, just in case we've been attacking before. Okay, otherwise, if we're closer, within 5 of it, then we can actually attack. So we set attacking to true and walking to false. Now, if we're not within a distance of 10 of the player, then we're going to go back into idle. So idle becomes true and the other 2 get turned off. Okay, so we turn idle off when we are close enough to the skeleton, and then we either attack or walk depending on that distance, the closer distance. Otherwise, if we're out of range completely, then it will just go back to idle. Right, so let's just play this and have a look where we're at now. So if I move up here, he'll start coming towards me. Now, notice that he's still dragging his feet along the ground and the animations don't work quite well. And what I want to show you that's happening is that before it can go from idle to walking, it has to finish playing this animation. So just watch this as I play it again, and I'll get close. See, he's sliding along the ground. It's because his animation for idle is still working, and it's got to finish. But we want to interrupt it so that it doesn't do that. And we can do that on these transitions. So we're going to actually interrupt all of these animations so it just goes straight to the next animation. Click your transition, and then in the inspector, you want to find where it's got this has exit time written, okay, which is above this timeline. Okay, and just turn all of those off. You might want an animation to play all the way through. Like what that attack animation, you may want him to actually stay there and play the whole thing. For now, we're not going to do that though. We're just going to interrupt it. Okay, and now if we press play, so he's in an idle state, and we get close enough, he's going to start coming after us. And then if he gets close enough, he will then go in and start attacking us. And he's going to continue trying to attack us until we manage to outrun him, at which point he goes back into his idle. Okay, so that's working really nicely. Now, last but not least, you might want to restrict the skeleton's vision so that you can sneak up behind him. At the moment, he just tests if you're within a certain distance, no matter what direction you come from. So we're going to now program it to check that if you're in his field of view, like at his front, then he will chase you, but you can actually sneak up behind him and he won't see you. Right, so just to illustrate this, I've got a picture I'll just bring up. Here it is. Okay, so here's our skeleton, our NPC, and we've already programmed in our this visible range. Okay, so at the moment it's a circle that goes all the way around him, but what we want to do is restrict the angle that he can see, so like this across here, and we're going to do that by working out the distance, the direction to where the player is and the direction that he is facing. And then if you're within a certain angle of that, then it will trigger our if statement that makes him chase after you and turn towards you. Otherwise, if it's outside this angle, then it's not going to take any notice of you. Right, so just go back to Unity and we'll open our code where I've already made the changes. These are really simple changes. So as you can see here in the update function, I've taken the direction line calculation. It was sitting down here. Okay, so I've taken that out of there and I've just moved it up here. Now that gets our direction that we need to calculate the angle between the forward direction of the skeleton and the direction to the player. So we use the vector3.angle function. Okay, that gets our angle. And then all we do with our next if statement is to put and angle is less than our field of vision, which I've got as 30. So that's it, those two lines and the and statement at the end of our if. All right, so let's run it and just see what we get. Okay, so we're starting outside of his view. I'm just going to walk all the way around the back so that we're not within that 30 degrees. And now I should be able to sneak up behind him. And I'll get right up close and he's not triggered at all. But then if I walk away, let me come back around the front and approach him head on or within that 30 degrees, he's going to turn and come after me. And then I should still be able to walk away and he will lose interest. Okay, so that is a very simple artificial intelligence algorithm. I call it the line of sight algorithm because you're using the forward vector or essentially the NPC's vision, field of vision, as to whether you've walked in there or not. So it's just some really simple trigonometry in there to determine that. So I hope you learned something and found that valuable, and I will talk to you again in the next tutorial.